Hi all. We are 2 minutes early, so that's like with Hermes and Kafka. We try to deliver events earlier than they are published. It's hard to do, but we try to do it, and I will try to show you how we do it. My name is Krzysztof Debski. I'm software architect, I'm a developer, I'm product owner of a bunch of tools that we use for all our internal applications, for all our services in Allegro group, and I would like to show you one of them, Hermes. Hermes is our enhancement to Kafka, and I would like to show you why we are using it, what are the drawbacks of pure Kafka, what are the improvements in Hermes. We will see something in Hermes, and then I hope you can use it in your own. So, why do we need a PubSub in our organization? We started from monolith. We built services, microservices. It's not like 10 microservices, 20 or even 50. Currently, we have about 250 microservices. It's hard to say the exact number because we have about 55 Scrum teams that works still on new microservices. So it's really hard to manage all of them, and it's really extremely hard to manage all the communication between all the services. So that's why we decided not to focus on every single connection between services. We decided to divide our application into multiple domains. By domain, I mean by DDD domain. So we have a user domain, we have a purchase domain, finance domain, etc. So we divided our whole application into multiple domains, and we focus on connections between on those connections that are between services that are between domains. So thankfully, this is only about half of the connections, so we can focus only about half of the services, but there are still a lot of them. So we thought how to manage those connections in the best way. There are two ways how to do it. The first one is the orchestration, and the second one is choreography. We thought about orchestration. We even bought one of the really expensive ESB tool. But if you think about microservices and what everyone says about microservices, you don't think about smart pipes and smart connections. You rather think about smart services and smart endpoints and dump pipes. You don't put magic into your connection. You just put the simplest possible connection ever. So that's why we shift from the orchestration, where the single tool is responsible for all the connections between the services, to choreography, where all the services are responsible for their connections. So that's why we decided to use Kafka. Kafka is a great tool that was developed about 4 years ago in LinkedIn. Currently, it is managed and delivered by a company that is owned by LinkedIn, Confluent.io, and they provide really nice and decent PubSub tool. But how the Kafka is built? In the basic words, it is like Kafka broker. If you are familiar with queues, with AMQ pair, it is like queue system, but distributed. I will cover it later. Queue system in the middle, and we have two libraries, one for the producer, that we can send events to Kafka, and we can manage topics, which we'll cover later. We can manage all the configuration in Kafka. And second one is the consumer library that pulls all the events that we are interested in, and we can process them in our application. It is also really important part that all the configuration of Kafka is stored in Zookeeper. Currently, in version 0.8, we are using 0.81. The newest one is 0.8.2. Zookeeper is the center of the truth for all the components of Kafka. All these components are connected to Zookeeper, and also consumers put their data into consumer. In Kafka 0.9, it's gonna be slightly changed. Consumers won't connect to Zookeeper. There's gonna be only connection between Kafka brokers and Zookeeper. And consumers for the job will use also Kafka and specialized topics. So, what is this topic and partition? Kafka is a distributed PubSub tool. So all the data that are put to Kafka is divided into topics. By topic, I mean the same data is homogeneous data, so we split it into topics, and because it's distributed, we use a partition key to distribute it to multiple brokers that are handling only the part of data from this topic. As you see, there is no connection between different partitions. So we can only read from one partition, and we can be sure that if add event is after one, we will read it after in another, but not with any other partition. It's not possible to synchronize the partitions because it's distributed. And if we have multiple partitions in our Kafka, how to connect to them? In pure Kafka, one consumer can connect to one or more partitions, but one partition can be consumed only by one consumer in the consumer group. By consumer group, I mean all the instances of single application, of single service. So if we have two different services that want to read from the same topic, we can have, for example, two instances of the first service. There will cover multiple of partitions. And if we have the second service, we can connect one-to-one. If we have more instances than number of partitions, we will have spare partitions. We will have spare instances. They cannot connect to partitions because there are no left partitions. So we are limited with sizing of our service to the limit of the partitions. So we need upfront decide how many partitions and how many clients we will have, because we can change it, but it's not as easy as we would like to have it changed. And how it is read from Kafka. As we see, Kafka is a pure queue in each partition. To the end of the queue, all the processors write events one by one, and it is written here. All the old events are removed from the Kafka. We can define retention time, after which all the events will be removed. It doesn't matter whether all the consumers consumed already these events or not. Kafka will remove it. If we set it to 1 day, it doesn't matter whether all the services are live for 1 day. We'll remove those events. That's why all the consumers write their offset that all the events till here were read by consumer group 2 and all this by consumer group 1. There is no instances of consumer because we can shuffle all the consumers between partitions. Kafka do it by their own. But if we remove all these events till here and we do nothing with consumers, they will have some unreaded events and we need to shift them. Okay, we have multiple partitions. We have multiple brokers, so how to handle it? It would be unsafe to store data in only one broker. So that's why we have idea of leader, where the data is written, and replicas, where the data is replicated. What is really important, that we only write to leader, and it can be replicated to replicas by Kafka. Here we have a leader and replica, and we cannot read from replica. We can only read from leaders. So if we have a leader distributed evenly, it is really easy because we have, we read this partition from leader 3, etc. We have 2 replicas that need to be in sync, and we have ISR. ISR means, those 2 replicas are in sync, so it means they have all the data that are on the leader. So what would happen if we just kill one leader? Let's kill leader number 3. So we see that partition 1 that was led by broker 3 was changed to broker number 1, and we have just only one async replica. And in partition 2, we think that nothing changed, but in fact we have one replica not in sync, so we have just one replica in sync. But what is really important, what happened if we just bring broker 3 to life? We see that after some time, it will read all the data from the leaders, but nothing changed with the leaders. So if we kill brokers one by one, we can finish with the situation when all the leaders will be stored in one broker. We can finish in the strange situation when we will have multiple of brokers with Kafka, and all the traffic will go only to the one leader. to the one broker. So that's the one thing you need to remember. With the partitions, there's also one more thing. We can decide by producer. It is no like global configuration. We can decide by producer how many leaders need to acknowledge that it saved the data. So we can have 0. It's like, okay, send and forget about the event. We can have 1, which means, okay, leader saved it, but we don't know anything about replicas. And we have -1, which means all the replicas that are written need to acknowledge the save. This one is really safe because we don't need to wait for the acknowledgement. This seems to be safe, but it's not. In the strange situation, we can kill leader, we can elect new leader, and all the events that were not transmitted to the newly elected leader will be lost. So we need to remember that, because we forgot about this. We thought that it's safe to store only on leader and it will be replicated, and we lost a lot of events because of that. Basically, in Kafka, there is no security, as I mentioned. There is a producer library that allows you to do anything with Kafka. You can create events, you can create topics. You cannot delete topics, because there's no such feature right now. It will be in 0.9. You can publish events to any topic you want. You can publish events to some other guy's topic, and you can read any events you want. There is basically no security. It's like open host. That's why we decided to build something on top of Kafka. We decided to build Hermes. There are a couple of things that why we decided. First of this is in Allegro, we are communicating with REST, and we are basically using synchronous communication with REST protocol. With Hermes, we can easily shift from synchronous communication, where those two services communicate to each other, to asynchronous, where it's synchronous via service and Hermes, because it must be. But Hermes stored all the events in Kafka and then send it via REST to the second service. What is great with this is that we don't need to change payload that we send. We don't need to change protocol. We don't need to change anything. A part of URL that we send our events. So we just change URL, send to Hermes, and Hermes will do the rest. So how the Hermes is built? It is basically the Kafka architecture. So we have Hermes frontend with Hermes libraries that exposes REST API, and we have Hermes consumers with consumers libraries that shifted from pull to push and push all the data via REST or JMS, or currently we are also implementing EMS for TIBCO tools, and we can implement any other protocol because we are ready for that. We have interfaces for that, and we send to any subscriber that we want to. There's also one nice thing with Hermes. With Kafka, what you put to topic, you can read from the topic. There is no such thing as message ID. There is no such thing as timestamp of putting it to the queue. With Hermes, we thought, okay, it might not be sufficient for us because we have multiple partitions per each topic, so we don't know what was the exact order of the topic of the events. So that's why we added message ID to each event that we sent to Kafka. What is really important is the UUID, so it is not connected to data that is in payload. We also added timestamp of sending data to Kafka, so we can check whether something wrong happened. And we also send this message ID back to the client. Because of that, he can change and he can correlate the data that was sent to Hermes and the data that was sent by Hermes. And he can compensate, and they can compensate all the events that might be lost. Okay, so we have that architecture, and we thought, okay, we need to provide our clients a reliable and stable broker. So we thought, okay, it would be great to have 100 milliseconds timeout for this send messages, and we thought it would be great. And we realized that we were wrong. First of all, we weren't aware of something which is called Nagel's algorithm. Nagel's algorithm is really great stuff to optimize your network. Because with TCP, you have payload and headers. Headers is a 40 bytes. If you have really small payload, you try to put as many data, as many possible events to one payload to optimize and to not send headers many times. And because of that, system waited for more data. The data doesn't appear, so after about 40 seconds, it sent those data, and we had to wait about 40 seconds just for the network. And the second one, strange thing for me was that we had 100 millisecond timeout on the client side. We used PHP for this, and we thought, okay, it's easy. We all use curl. Let's set up read timeout for 100 milliseconds. We respond in less than 100 milliseconds. It was like 60. And then we had a lot of timeouts. Well, what the hell? It was because of the high load of the machines. And because of the high load of the machines, curl wrongly calculated timeout. And it was like, okay, we used sysdig, we checked it. Oh, great. We used sysdig, we checked. We checked whether we can send within this 100 milliseconds, and then we realized that after another 20 seconds, someone read this data from the socket. So we decided to count timeouts not on the client side, but on the server side. We decided, okay, we have network administrators. They can do their jobs. They know what they do. Let's focus on the 65 milliseconds on the client side. And it wasn't also easy. In the real operation, the normal operation, in the real world, we just post some data to Hermes. We just post data to Kafka. We have one acknowledgement. So leader answers, okay, everything was saved. We answered, okay, 201 created. Great. But in the real life, it's not like the great. We've realized that in some strange situation, Kafka, when they rebalance their replicas, etc., they can answer even about 20 seconds or more. There might be even worse situation when Kafka broker is dead. So we decided, okay, we wait for the 65 milliseconds, and after nothing happened, we sent, okay, HTTP 202, we accepted your request, we tried to send it to Kafka, we do our best, we save it even in our queue, but we'll do it later. If you need to have real acknowledgement, resend it, because we have at least once resend it, but we'll do our best. Currently, we can do it, but it's just for the clients. We also decided that if we read from one partition, one event by another, you can finish in the situation where some of the events cannot be processed by you. In this situation, let's imagine that we have events marked in orange that were processed, and events that are white cannot be processed. In pure Kafka, we just commit this offset as last event that was consumed correctly, and we cannot mark those as consumed. That's why we have internal queue in Hermes consumer, where we store all the events that weren't consumed properly by subscriber, and we try to resend it. After we resend it, after we resend the oldest one, we shifted commit offset. What would happen if we lost this queue? Nothing. We will change the events again. That's it, at least once delivery. So what really happens if we receive 503 from client, or network is unreachable, or anything? We just check TTL, because we told our clients that we can try to deliver every event for about, it's configurable. Usually it is like 1 hour, and we will try to do it for 1 hour. If nothing happened, we will remove it from the queue and commit to Kafka. If not, we'll try to do it again. But sometimes there's something wrong happens with our clients. Usually they answer with 200 HTTP, but sometimes they are unreachable. Some services is down, some instance is down. So we negotiated with our clients that we have ratio, how to send, how many events sent per minute. If everything goes all right, we send 100% of those. If something goes wrong, for example, we get network unreachable, we adapt to the number of events that cannot be can be processed by the client. So we lower the number by 10%. It's configurable till one event per second. And if client even cannot process one event per second, we shift to what I call survival mode, which is one event per minute. We just ping our consumer, are you alive? Are you alive? Okay, I can send more, and 100%. It usually works. I had one situation with one team where they respond in more than 1 second. For me, it's a really long time. And it was like we lowered the number of sent events till 1 per minute. And they just were surprised. Oh, what happened? Well, you answered really slow. Well, 1 second is not so slow. And if you compare it to 65 milliseconds, so that's why we need to have asynchronous communication. If we have synchronous communication with 1 second, it would be a disaster. And we still have some strange issues. Even with this storage for the unsent events to Kafka, even with Kafka with acknowledge -1, we still had some events that were lost. That's why we decided to do some tracker that we also have in the whole stack, where we send the information about all the events that were published, all the messages ID that were published, and we sent also the information about all the attempts that we try to send event to the subscribers. So if subscriber was unreachable, we save it to the tracker. So that's why we know and we can say exactly what happened with the subscriber. We also decided that we need to focus on the security of Helmes. With Kafka, you can do whatever you want. We decided to divide all the topics into groups. Group is the thing that exists only in Hermes. For Kafka, all this is topic. But we decided to have convention that all the things till the last dot is the group name. Group name defines what you can do with all the topics. It defines the authorization for all the tasks. You can, if you have group, you can do whatever you want with your group. You can define subscriptions. You can define you can define whoever can change something. But there is lost of one thing. We don't prove that only you can send topics to this, only you can send events to these topics. So because of that, there's one more thing that needs to be secured. Anyone can publish to your topic. We want to secure it, but it works currently quite nice. One more thing with Kafka is that it works really nice in one data center. It can work with multiple regions, with multiple zones, but there is one issue about the network latency. If you want to acknowledge from the multiple regions one event, you need to wait a lot of time. This is like 8 milliseconds, which is like a huge amount of time. So that's why we decided to shift Hermes, to divide Hermes into 2 data centers, or to even more data centers, and to have one tool that manage all of those data centers and to manage all of the topics, all of the authorizations, etc. And if you are binded to one data center, for example, you use service discovery and connects to Hermes frontend in one data center, all your event will stay in those data center. But all the topics are replicated, but only topics, not events. So if you will be bind in just 1 minute in the second data center, all your events will be here and will be sent by this consumer. It's because of that we can be much more safe. We think about do some kind of asynchronous replication between data centers, but it's not the part of this image. Because slides are rather easy to build and to show, I would like to show you something more. Hermes that I showed you already is open sourced. We open sourced it on Friday, so you can go to github.com/allegro/hermes and download it. What is better for me, we have here Docker files. You can get here and to use our getting started guide and install it on your own environment. Surprisingly, I have it installed here, Docker PS. I have here slightly more containers than in the normal application. But in the normal application, we have Kafka, which is obvious. We have Hermes frontend that we send all the events to, which is listening on the port 8888. We have Zookeeper that I covered. We have Graphite. We have Mongo, and Mongo we are using for the tracker. We have also consumer. Oh, here we have also consumer that sends all the events to them, to our consumers. So let's look at our Hermes. Here I have Hermes console, which is not currently part of the open source. It will be, but currently it's just a thin wrapper on the REST API. You can do whatever you want with console. You can do with just REST client. So I have here a demo and one demo topic. So let's start from the beginning. Let's build some group. Hermes password is not important here, but let's build some group atmosphere. I will be the technical owner. Some team will be support team. Some team at Allegro PL will be the contact. It's important for us to know who to contact if the events are lost or if there is something wrong. Support team, internally, we are using to connect to Active Directory, which you can implement by your own. And we are using it to authorization to each group. So we have atmosphere group. Let's build some topic. Topic 1. Test topic. Retention time is the time that Kafka will store their data. You can use any multiplication of 1 day, but from my observation, it is not safe to use 1 day, because if you use 1 day, it might be any time between 0 and 1 day. It's usually 1 day, but you are not always sure. So we have just topic. We can use our postman and send something to this topic. It's just called atmosphere topic. And we just sent. We have 201 created. We have Hermes message ID. And if you looked here, we have one message police. Oh, hooray. Yeah, and that's topic. We have it here. What you can see here, we have tracking enabled false. We have tracker in this Docker, but you cannot set it up with console. Let's change it with REST API. So let's list topic. I have atmosphere topic 1. Let's look what's inside. We have name, atmosphere topic, description, retention time in days, validation false, which means I can validate schema whether I sent good data. And let's change those data slightly. Let's change tracking enabled to true. Send. Okay, we changed it. So let's send some data to this topic. And we have 201, unfortunately. I hope it's gonna be something. Okay. Maybe the collection names, because as I mentioned, we are using Mongo. So we have published messages. Collection published messages are the messages that were consumed by topic, and sent messages. It is configured by each subscription. So let's look at the published messages. Okay, we have here our message ID, when it was sent, and that everything was success. But let's mess something up. Let's kill Kafka. Docker PS. Kafka. There's no Kafka. So let's send some events. Oh, we have 202 accepted. And some more 202s. And let's look at Mongo. Okay, we have, as you see, we have here events that are status in flight. So those events are only in producer. There are no events in Kafka. Let's bring Kafka to life for a moment. Docker compose up minus dem minus no deps Kafka. Recreating Kafka. And we'll have it alive. We can look also at Graphite to look at it. If we look at Graphite, Hermes producer, oh gosh, let's look at the status codes. We have here 202, 201, and let's look at the published events on the topic atmosphere. Let's have it for the last 20 minutes. Published. Oh gosh, I published to the topic, the demo topic. That's why. Let's look at the demo topic. And here they are. So they are published. Oh gosh, still we have intf 20 minutes. You cannot see it because I published over 80 kilo events there, but they are here. Let's shift it to some really nice. Let's use some nice tool like Siege. Let's look at the event. Let's send some events to atmosphere topic 1. Okay, so they are sending. So we can look here, graph data, remove all of them. And let's look at the published events here. Okay, so we have here for the last 10 minutes. As you can see, we have some of the 202s because Kafka was for some reason unavailable. Sometimes it happens. It's just Docker. I use boot to Docker when I try to use it for the more data. It was like, okay, it's like 1.5 K events per second on the MacBook Air with a bunch of the events on my, with a bunch of the Docker containers on my computer. So let's look at one more thing. And that would be the last thing that I would like to show you with this. Okay, so as you see, we answered with 202 because Kafka wasn't able to handle all the traffics, but we also tried to send it. So we wasn't able to send it with 65 milliseconds, but as you see, those are published messages. So just after the couple of milliseconds, we published it by Hermes. So that's really nice stuff with Hermes. Even if Kafka is not able to handle it, Hermes can handle it. It's surprising good for me. Okay, so let's, oh gosh, no here. So let's finish it. Let's finish the presentation. Okay, so what we plan to do. We still see that there is huge overhead with network, with JSON that we are using currently for communication. So we want to switch to Avro. Avro has two huge advantages for us. One is the less overhead and less network footprint. And the second one, that you can handle all the schema of the events with the events. So even if we have multiple schemas with one single topic, we will still have it with Avro event, with the event itself. And the second thing is the one thing that was released on Friday. It's RFC 74540, which is just HTTP2. HTTP2 is officially released, and that's why we want to shift Hermes to HTTP2. We want to have it in this quarter. The one more thing that I really don't like currently is open. There is no security with publishing messages. Anyone can publish. Well, it is. You can write it on your own because you just can secure the endpoint because there are different endpoints per topic. But we want to have our internal service authentication, and we want to have easy and maintainable way to manage all the authentication of all the services. And what we've learned with this. We thought that it would be great to have exactly one delivery. It's really great thing, but it's not possible. It's proven. It's hell to provide it to our customers. Apart of that, we are switching to idempotency, and we are switching to at least one delivery because it's much easier. We thought with the beginning of this project that all the clients are the same, that we need to provide only one policy for all our clients. And currently we are seeing that it was wrong. We have different clients like a recommendation platform, that if we lost 10% of events, who cares? And we have finance platform and billing. If we lost one event, there's hell. And one more thing, early adopters are your friends. Because we worked close with some other teams from our organization, it was great to handle all the bugs in the beginning. If I could shift to those times, I would use much more early adopters, because only with early adopters you can use and deploy your application really, really good. And that was all. Thank you. I encourage you to use Hermes. I encourage you to download it and look at our code. Thank you. If you have any questions, I have some T-shirts with Hermes logo. There are just a bunch of them on the board. If you have, please ask some questions. Those are really nice. Yeah, great, thank you.
Thank you. Hi, I'm Daniel. My question is this: you said that you want to change this synchronous communication to this asynchronous communication, but what the latency of that? So if you are waiting even for the response, what's the latency overhead?
Okay. If you're waiting for the response from Hermes, you wait only for the 65 milliseconds. There is no business logic with this. If you wait for the process of the billing events, you need to wait, for example, 1 second. So if you shift from the synchronous communication, there's no 1 second wait, because we are handled as Hermes, and you wait only for this synchronous sending of events, which is really lightweight. So it's like 65 milliseconds for 1 second. So that's why.
So did you switch to communication between domains going through Kafka or Hermes because you wanted to decouple your domains? Is that why?
Also, but it's not only the reason, but it's also the reason. But we also wanted to store all the events in Kafka, because it's nice, because we can store them in Hadoop with Camus, and we have a lot of data that we can process. But also decoupling, and well, I don't care what happens within domain. But between domains, we need to decouple them as much as we can.
So is there some element of event sourcing going on underneath?
We are moving to event sourcing. We are not here yet.
Okay.
There's one more question just behind you.
I have a question about the event gone wrong. So
okay.
when for example one backend doesn't work and don't answer, then what are you doing with the next event in the next events in the topic? You are serving.
We are sending them. We are just store the events that weren't sent till the TTL, and we are lowering the amount of events that are sent per second, because we are assuming that something's wrong.
Okay, thank you.
Thank you. Okay, thank you all. It was great to be with you here, and I ask people that ask questions for the T-shirts.
Thank you very much.